Hello. Here's another video that will hopefully actually be seen and will actually hopefully be part of a fully graded project, but that will be seen in the future. I am still recording this because I went through the trouble of completing this, and it was actually pretty fun once I actually got into the flow. Like last time, like my last project, I also, well, first off, I am Carlos Garcia. This is my project 2 for my computer science 167 class for Emir Shamran, or yeah, something like that. That class, um, my computer science class, and this here is also my project right in front of me. Like last time, I got some help from friends, but they pretty much never gave me any code directly, and I had to figure and write all of this myself and figure out what to do. So let's walk through it. So, like the project said, we have two different Java files. We have prompt bank, which contains everything in regards to the arrays. We have the array of questions and statements. We establish those here, and then in prompt bank we initialize them with strings that contain three different items inside. And each of these three different items is then assigned an actual string that will be used later within the program itself in an explanation I will go over shortly. So as you can see, the three items inside of statements in the statements array are given this, and then as well as questions. And then as well as in here, we initialize the statement array so it knows what is inside of those, and then we randomly choose which one will be shown whenever get random statement trunk is called in the project ELIZA file by using an RNG method, which is just mat_floor and then mat.random. Uh, this basically creates a number between 0 and 2 because it goes into an integer. And because of that, um, every number that is created from a double of this thing is essentially, although I won't not pretend to completely understand the exact mechanics about it, I just know that math on random, when it uses an integer, will create a number, will initially create a double number between 0 and whatever number you put here as it being multiplied by. And for whatever reason, when you do an integer, it rounds down and will instead create, instead the range of numbers created from this will be from 0 to that number minus 1. So in this case, we're able to create zeros. We're able to create numbers between 0 and 2, which is precisely the numbers assigned to our different arrays, the different items inside our arrays. And so whenever this number is rolled, we get one of these. And then either the statement or the question is taken into and stored into a string called temp statements. And inside that string, we replace the blank words that we left in here with the words that our user will input once we start Project ELIZA proper. So that's basically everything that's happening in prompt bank. As for ELIZA, we have a couple of scanners that I separated just for prosperity's sake. It's helpful to be able to know just from a glance what each scanner is. And then an extra thing that I'm basically just quality of life. Most of the actual mechanics and guts for the program are inside main for ELIZA. So we set up a scanner just in case, although I don't think it gets used. I don't think it's ever actually used inside of a main, but it's good to have that just in case. We establish a connection with the prompt bank class here. By the way, these two can interact with each other because they're inside the same package. So if we go here to project 2 and go to source, as you can see, they're inside the same package. If the instructor were to use it, they probably need to do a similar setup to get it to work. But yeah, by creating this new object, we establish a connection between the two files, and we can use things from prompt bank as long as we start any item that we use from there using prompt bank dot and then the actual method that is inside prompt bank, the file. And then we just initialize different variables for string, response, word, failsafe. This basically just exists so the program does not get pissy about doing all of this in the future. Um, and Boolean repeat true, which is basically just a switch for the whole program in of itself. So as the as the project instructed us to do, we have Eliza saying, "Hi, my name is Eliza. What is your name?" So if we start this here, if you go here, we can put in my name, which is Carlos Garcia. And I also put in the little quality of life thing that I said here, which basically removes any punctuation, or at least just the one punctuation that you put in. If you put in more punctuations, I am not responsible for it not working as well. I'm pretty short on time, so I couldn't figure. I mean, there probably was a way to make this work better, but I did not have time to really consider that, or the will. So if we put in my name, Carlos Garcia, that will not work. Well, not too late for regrets now. Anyway, Carlos Garcia, tell me what is on your mind today in one sentence. And you can see that's where we go next. And we enter this little fun loop. So, here we can put in a variety of responses, as the project said. And we can tell Eliza a variety of things. So, if we tell Eliza something like, I'm not sure, I enjoy baleadas. Are good, but I'm not as big of a fan of tacos. As you can see, the actual punctuation removal actually works properly here. Not sure why it didn't work properly the other times. I now realize why it doesn't work properly. Well, again, it's too late for me to really fix that. This is a little embarrassing, but anyway, it's not part of the assignment entirely. It works where it needs to work. That's all that really matters. So as you can see, because we ended it in a punctuation, it will give us a statement. And if we keep talking and we also say bananas and apples, and don't put any kind of punctuation, it will still do a statement. And as you can see, it's selecting randomly from the different selection that we had in the different arrays. And then if we ask a question, bananas and apples, it will ask us a question. And then if we put an exclamation mark, bananas and apples, wow, drama, bananas seem important to use it, so those apples. Please tell me more. Now, if we want to, as you can see, here's a great failsafe. Because if you only put in one word, or in our case, no word at all, you would result in the index of the system here that we use to detect whenever the first word is. It would result in the index of space becoming -1 if you put nothing in. So in order to not have the program just crash and burn because of that, we put in a failsafe where instead word 1 and word 2 are set to be equal to just whatever response is, instead of going through all of this. And as you can see, it works pretty well. I mean, it looks weird, but it works. It does not break Eliza. Eliza keeps trucking on. We love you. So then afterwards, if we put in exit, no matter our punctuation, Eliza gives us a choice if we want to run the session again. So if we say yes, it starts a loop over, which is what this section here is. For when it exits here, we get into a little loop, and if we say yes, Eliza, we go through the same steps that we had before at the very start of Eliza, and then we break the loop and we get brought back here to response to do the whole thing all over again. So just to show that real quick, what is your name? Carlos. Hello, Carlos. And banana. Banana, let's talk about it. Great. And now, if we want to exit for real, you want to run the section again? And we say no. Goodbye, until next time. Smiley face. And, as you can see, no more Eliza. And that's my program. Basically does everything that the assignment told me to do. And to be frank with you, it was pretty fun to do. All things considered, after getting over the dread. Again, there were some a little bit more polished things I could have done in the end, but I think it came out pretty well. So that's it. Goodbye.